Hello, everyone, and welcome back to another episode of Better Together at Science with Shinrai Sensei. Today, we are going to talk about the climate, and this is going to be a very in-depth discussion on how climate works, but also facts about the climate. So, climate works basically, it is extended weather patterns over a long period of time, is how we tend to refer to climate, right? So, the climate of the Sahara Desert is extreme heat, low rain, right? And any area that gets less than a certain amount of rainfall a year is classified as a desert. That's why Antarctica is actually classified as a desert. Most parts of Antarctica are classified as a desert because they receive less than a certain amount of precipitation every year, right? So the climate of deserts is that they are dry. Not always hot, but that they are dry. The climate of rainforests is that the water cycle is kind of on an accelerated timeline in the rainforests because of the dew or the rain that sets on the forest leaves and stuff like that will evaporate when the sun hits it, which causes it to go back into the water cycle almost immediately. It condenses into clouds directly above the rainforest, and then it falls down again as precipitation. This is why we call it a rainforest, because these rainforests perpetuate rain by their very existence, right? You have areas of, climates such as temperate climates in the Northwest or the Midwest and stuff like that, where you have a lot of the best conditions that cause tornadoes in the Midwest, some of the most dangerous weather phenomena on Earth, right? These are caused by the factors of the Midwest, such as very flat, few trees, not a lot of wind breaks to disrupt wind patterns that end up turning into cyclonic winds that develop into tornadoes, right? So the climate in these areas will tend towards thunderstorms will sweep up in between the mountain ranges of the Rocky Mountains and the Appalachian Mountains, and these hurricanes that come up through the Gulf will just transfer into thunderstorm systems that will come up through the Midwest, right? But then you also have cold air will come down through the same passageway between the two mountain ranges, and it will clash with warm air that's rising up through those two mountain ranges. They clash in the middle and they generate a lot of thunderstorms. This is where more of your tornadoes are going to come into play, because cold fronts from the north and warm fronts from the south will clash and generate very strong thunderstorms that eventually turn into storm cells that form tornadoes, right? So we have a general understanding, kind of climate. But humanity doesn't understand climate as well as we want to, and as well as we think we do. We don't understand anything as well as we think we do, but let's focus on the climate, okay? Simply put, we estimate about the climate a lot because we can only go back with information that we've collected over the time that we've recorded it. Well, we haven't really had the same method and the same scales to measure temperature or to measure time or to measure, all of our measurement systems have actually really recently been changed. And so trying to measure things in a way that we consider empirically accurate today is a very modern phenomenon, and that's kind of been the problem with climate science and talking about the climate. The simple fact of the matter is we don't have a full grasp on the climate as it is, so it's very foolish for us to say we understand how the climate works and we understand that the climate needs to be a certain way. Okay? But the number one rule about the climate, as I have written up here, the climate is number one thing is always changing. It is always changing. And homeostasis, which is what our body does to try to maintain balance, right? We use that term in anatomy and physiology to describe the phenomenon where the human body tries to maintain a specific amount of temperature, a specific amount of water in its system, specific amounts of sodium, protein, lipids, and carbs. And your body's trying to operate based on the input that it gets from you, but it's also trying to operate based on the environment that it's in. When you are hot, your body will sweat in order to shed heat by either getting cool air will blow on the sweat, thus reducing your body temperature, or the sweat's more designed purpose is to evaporate off your skin in order to reduce your body temperature by having the sweat absorb the heat and evaporate off, thus reducing your body temperature by making the surface of the your skin radiate heat rather than absorb heat, right? So homeostasis is that phenomenon in anatomy. Homeostasis is a bad thing for the environment, right? Homeostasis of climate is actually deadly. So I just am going to use the term homeostasis to refer to stagnation, right? You could also use stagnation, so, you know, we'll just put stagnation above it. That way it's clear. But stagnation of the environment is going to cause a wealth of mass extinctions. Like a mass extinction level that you probably have never even imagined before. The Great Dying that we saw at the end Permian extinction, right? That will look like nothing compared to the mass extinction you will force if you force the world to stagnate. I mean, it's beyond our measures right now to force the world to stagnate. We can't stop ocean currents. We can't stop air currents. We cannot stop how the ocean flows because of, you know, different densities in different parts of the ocean and different biological activities that cause temperature variations in different parts of the ocean, right? The fluidity of the planet is what causes the climate, right? The amount of fluid that covers the planet, that is part of the planet, is really what drives climate. Because the climate is entirely driven based off of air currents and water currents. So the warm water from, you know, the equatorial region of the planet will make its way north into more Arctic regions, and the Arctic regions will make their way south into more equatorial regions, and the water flow will continue to flow north and south to try to equalize the temperature. But the simple fact of the matter is, they can never be equalized. That is the catch-22 of it all, right? That's the bait and switch, really. All fluids want to flow until they are at equivalent temperatures at equivalent depths, right? They are at equivalent, you know, they're all level and they're all the same temperature. That is what fluids want. But the Earth's oceans are so massive and their densities are different in so many different places because of, you know, marine fauna or because of saline content or because of how much geological activity there is under their surface. There is a massive fluctuation. Different parts of the ocean have different temperatures, different densities, different chemical composition, and different marine biology. All of these like to affect the environment a lot. They like to affect climate a lot. And the only way for the Earth to ever reach a point where we could stagnate the environment is if the entire surface of the planet was to be uniform in its in the ocean depth and in the land heights and in the geological features that we notice. We'd have to change so much about the planet would be virtually unrecognizable, right? And weather phenomenon would be completely unpredictable based on the models that we understand today. We would have no way to understand how this system would work. And that's only hoping, really hoping, that the system would work in a way that we hope it would. What we are trying to do by saying that climate change needs to be stopped is we are trying to force our desire for comfort onto a planet that is in need of constant change. Life needs to constantly change. It needs to constantly have pressure on it, because otherwise life stagnates and it dies out. We've seen it time and again. Mass extinctions happen because animals get too comfortable. Animals get too reliant on things staying the same. Every mass extinction we've ever seen is usually a result of the species have existed for a very long time, so they've all somewhat stagnated in the positions that they are normally in. You will see, the large grazing herbivores will be in the large grazing herbivore niche, and the large tree top eaters like your giraffes and your sauropods and stuff like that, some sauropods I should say, will be in their niche. You'll have the large predators that eat the larger of the herbivores will be in their niche, and the medium-sized predators that eat medium-sized prey and small prey will be in their niche, and so on and so forth. The niche partitioning is also a slightly flawed idea, but that's a discussion for a different time. But every single mass extinction that we can think of has always been a result of animals being overspecialized. They are overspecialized to the point that they end up dying out. And the only animals that tend to outlast mass extinctions are generalists, are animals that are omnivorous or that are small or a combination of variables, right? So every single mass extinction we've ever observed is because the climate changes due to certain factors, whether it be naturally forming factors such as simply the Earth's cycle of heating and cooling that it naturally goes through, whether it be because of volcanic activity that suddenly arises, like what the end Permian extinction is most likely caused by was volcanic activity in Siberia. And then you also have the KT extinction, the most famous extinction that everybody knows about, and that one was likely a chain reaction launched off by the impact near the Yucatan Peninsula area of a massive couple kilometers wide asteroid, right? So we understand that the climate changes, and anybody that's actually a climate scientist will tell you that the climate changes. The debate that they don't have an agreement on is that climate change due to mankind? They can say they agree on that all day long, but publications tend to lie about what scientists actually agree to. And simply put, the extent to which human involvement in the environment can be even measured is the very limited scope that we have of the experience before human involvement in the environment. We literally cannot experience the environment without human intervention. We can experience it without certain human activities and certain human inventions, right? We can experience the environment without certain key parts of our modern life. But we cannot ever truly measure what the world was like before we were here, because the factors that don't get trapped in the rocks, don't get trapped in the very young ice sheets that we still have today. The Earth was a lot warmer millions of years ago than it is today, to the point that we did not have polar ice caps a few million years ago. This was actually relatively recently. And so the measurements that they take out of polar ice caps are also flawed, because they require the polar ice caps to have existed. And the polar ice caps have not existed for the entirety of the time mammals have ruled the planet even. So it's faulty logic upon faulty logic that is used for climate activism and climate politics, okay? Do not succumb to climate politics and activism. Please take everything to its logical endpoint. And the logical endpoint of we need to stop climate change is we need to stop the climate from changing ever, at all, in any way. And the question you just need to ask when it comes to climate change and when it comes to the debate on climate change, the question that needs to be asked inevitably is, So if we stop the man-made climate change, if we cut everything out that is man-made climate change, will that be enough? Will that be enough? Or will we say that the climate changing still needs to stop? Even if we cut everything out of the system that we do, which is impossible, but it's also really negligible that what our impact is. In fact, it's arguable that humanity has caused a green boom by being more industrial. But that's beside the point. Simply put, we can't ever measure a world without human intervention. We can never measure that world because we will always be a part of it. I can't remember the principle in science, but by the very nature of observing it, you are changing it. So we, by the very nature of our observing the climate, are changing the climate. We are never going to be able to measure what the system is like without us. No matter how much we theorize what it was like without us, we will never actually be able to 100% confirm without any fallibility in the measurements, without any difficulty with collecting data. We will never be able to confirm 100%, one way or the other, where the climate is supposed to be, with or without us. All we know is that the climate is something that is beyond our control, and we are trying to control a system and play God. So, I think that pretty much covers it for today. Like I said, just take every single thing that, if you ever have a question about it, just take it to its logical endpoint, and if it still stands up at its logical endpoint, then it's a good idea. But if it doesn't stand up at its logical endpoint, it's a horrible idea. And the climate scare that they're trying to get you all on right now is not, it's not logically consistent, and it's also an extremely illogical point of view, because the climate always changes. That's the number one thing about it. And anything that would stagnate the climate would literally have to kill all life on the planet in order to stagnate the environment. Not to mention, the planet would probably have to be moved somewhere outside of the Goldilocks zone that we currently live in order for the planet to have any reasonable consideration for homeostasis of the environment. Because the Earth would literally have to snowball in order for there to be some level of homeostasis. And even then, the climate would still exist, because the climate would, by the very nature of the sun and the Earth interacting, is what causes the climate, right? The climate that we experience is all due to the sun and the Earth interacting. And we have really no input on that matter. So, a little bit of a more dour episode today, and a little bit longer, more rambling kind of episode. But I hope that you guys stuck with me to the end. And if you guys have any questions about anything, or if you want to disagree, I'm sure this is going to be, a video that gets some dislikes and some negative attention. But it really needs to be said that the climate panic and the moral, climatologist ideals are very harmful to the general state of the human race, but also to the general state of the world, because it shows a clear lack of understanding of the fact that change is the norm, not the exception. So, just so long as you can remember, change is normal and stagnation is abnormal when it comes to life, when it comes to climate, when it comes to all of that. Everything that we need in order to survive relies on change. We have just convinced ourselves that stagnation is better for us. But life requires change, and the climate requires change. So, like I said, this will probably be my least popular video. Might be my most watched, but it'll probably be my least popular video by people that won't really listen to the articulation of the points, or won't really listen to any of the discussion that I've done on the topic. But I hope that you can at least listen to this and understand my perspective, and understand that I was taking the climate change and halting climate change idea to its logical endpoint until I found that it was just a fallacious argument. There's nothing to be done in that matter. So, if you guys have any questions, want to disagree, I look forward to any interaction you guys get me in the comment section. And I do look forward to seeing you guys next week for another science episode, as well as math and English. So I look forward to seeing you next one. Peace.